Hello and welcome to Tool Time, Building Your Cybersecurity Architecture Planning Toolbox. I'm Diana Kelly, founder and partner at Security Curve, and joining me today is
Ed Moyle. I am a software security principal with Adaptive Biotechnologies. Though if you know my name, it's probably from ISACA, where I ran the research group there for a period of about 4 or 5 years.
So if you're a fan of COBIT, you can in part thank Ed. He worked on that for years.
I worked in some COBIT to some COBIT into this. So there you go.
More COBIT.
Everything needs more. COBIT.
We are virtual, as everybody knows, but we're also live. So we're here with you live in addition to this being pre-recorded. So please, we're here to answer questions in the chat. So as we go along, don't worry about holding your questions to the end. So we can chat with you interactively during the session too. And with that, let's get started. So our agenda today, we're going to give you a little bit of an overview about why tools can help with cybersecurity architecture and really what you want to do to have a successful cybersecurity architecture. And then we'll dive right into the tools. There are 3 different categories of tools that we'll be going over: analytical type tools, informational, and the design tools. And then we'll give you some guidance on how to bring this all together. We do want to mention that every tool that we're referencing throughout the talk are free and open source. So they're all FOSS tools, so they're all available for you to go take a look at. And we have a list of references at the end. Don't worry about on every slide saying, oh, I have to capture that, because we also have a list of references at the end so that you can find these tools after the talk. So to get started, that you can probably tell is actually me with the towel on my head. And we have an important point here, because if you're a fan of the show South Park, you may be familiar with Towley. And Towley's favorite phrase is always, "You're a towel." And so we kind of, in a lighthearted way, wanted to remind everybody that we, the human beings, are the strongest and most effective tool in the toolbox.
Absolutely. All right, so let's start our deep diving into the actual architecture process. We're going to be moving very quickly through this. So just like Diana said, at the end, we've captured all the references, for you to review at your leisure. But the most important thing, if you look at kind of how architecture is done, right, or how it should be done to be disciplined, right? You want to have kind of a normalized, a repeatable process that you can follow to get to a robust and resilient architecture at the end, right? So, there are some principles to keep in mind, right? You don't want to necessarily overinvest. You don't want to boil the ocean. You don't want to, you need to be able to react to changes. So for example, with COVID-19, right, we're all in a situation where it needed to be adaptable. And then when it comes to the data that you collect, more is always better. So more is always better. So just in have these things kind of in your mind as we talk through first the architecture process, and then kind of how the tools fit into it.
Yeah, and how you'll be successful with them. So what's the problem, though, that we're trying to solve? There's always a problem. And in security architecture, one of the big problems is that it's incredibly manual. The process takes a long time. There's not a whole lot of automation. That's why we really wanted to focus on what tools were available, because we've seen, as we've worked on cybersecurity architectures over our careers, that it can be really hard to get everybody together on the same page. And because it's so manual, you're losing a lot of that repeatability and some of that like tribal knowledge. So some of these tools really can help to address that problem, because it really doesn't have to be completely manual. There really are ways to make it better and easier for you to accomplish the architectures that you're working on. And one note that we probably should have said up front, Ed, but we had forgotten, is that a lot of this talk is actually based on a book that we wrote called Practical Cybersecurity Architecture. So in addition to exploring the tools after this talk, that book can also take you, if you want to get deeper into cybersecurity architecture, a lot of these concepts are explained there, but in more detail.
Absolutely true. So the 3 different categories of tools that we're going to be talking about, right, is we teed them up: analytic, informational, design tools. But what does that mean, right? At a high level, what does that mean? So from an analytic standpoint, Basically, what there's kind of a process that these fold into, and in terms of kind of understanding where you are now, both from a like a gap analysis standpoint, so kind of the difference between where you are now and where you want to be, across a few different dimensions that we're going to talk about from a risk standpoint, and then also from a threat environment standpoint. That would fall under the category of what we're calling analytic tools, or analytical tools, if you prefer. The next one is kind of all about data gathering. And so this is mostly like understanding your environment, gathering telemetry, gathering metrics that you can use. We'll spend some time talking kind of through that. And then lastly is the design time element, the documentation, the modeling, the things that you need to do in order to support both the expression of your design to someone else, which is important, but more importantly, I would say, just kind of the way that you kind of finalize it yourself. So people always think about documentation as, how do I explain this to somebody else? But also keep in mind that as you're creating it, you're almost explaining it to yourself and working through a lot of these problems that if you didn't go through that exercise, you would be needing to deal with real time on the fly.
And if you've ever done a really complex architecture or even written a very complex research document, you sometimes find yourself getting lost. Or if you've written a really big complex piece of code, you can kind of get lost in your own work. So it's such a great point that you also want to document it, not just for others, but for yourself too, especially in these bigger, more complex projects.
Absolutely.
Unless you have a perfect memory, which I sure don't.
I also do not.
So the architectural process at a high level is really around understanding your current state, validating that, using metrics, using measurements, and then documenting where you are and where you want to go in the future state. So if you see those 3 steps within the architectural process map to the categories of the tools that we're going to be talking about. And we broke that out. That's why the tools, we brought the tools into the architectural process rather than layering the process over the tools.
Absolutely true.
Getting started with the analytical tools or the analytics, this is about assessing the current state.
Yeah. So basically what the most important thing, and at least in my opinion, that you want to do is you want to understand kind of where you are now. And you want to understand that in a few different ways, right? Because you want to understand kind of what you have, and then you want to look at kind of how it can be attacked, right? So understanding the threat environment, and then you could put those 2 things together, and at the end of it, you're going to understand, you'll have a risk-based view, right? So to start that process, you can look at gap analysis now across a couple of different dimensions. Now, in my mind, I'm sure there are dimensions beyond this, but in my mind, the 3 most important dimensions to look at are what we're calling effectiveness, maturity, and efficiency. And there's other names for this, but effectiveness is basically like if you've ever been through like an audit, or if you've done kind of like a ISO assessment or something like that, basically what that is that's to help you understand kind of if you have a given control or a given countermeasure or what have you in place, right? So this is basically like looking at your implementation across a documented baseline. Now, the ones that we've listed here are COBIT 5 because, of course, right, I worked for ISACA for a long time, so I can't let it go without the COBIT, right? But there's also others too, like SP 853, the ISO 27001 standard. In particular, Annex A, the reason why Annex A as opposed to kind of the rest of the standard is that, because we're talking about controls here, and, the earlier sections of the standard are really about some of the things that are going to come later in the process, like risk management and program management and what have you. So we're talking about the controls piece. So that's really kind of looking at it from a do you have this? The next one is kind of your maturity. So it's important to understand if you have it, but then it's also important to understand how you're doing it. So one way, think about something like spam filtering, right? There are 2 ways that you could do this, right? Like one way would be that you implement a spam filtering tool. Another way would be that you could hire a legion of people to like actually read emails as they're coming in and sort them into spam versus non-spam, right? Now, the manual approach and the automated approach, while they do the same thing, have very different characteristics, right? So maturity refers to the maturity of the processes the process implementation supporting it. So if you look at models like the CMMI, right, the capability and maturity model, or if you're looking at something like CMMC, right, for doing validation, maturity evaluation and so on, this is really kind of one strategy to do that, but it tells you more about just, do you have this control or not? It's telling you about the level of maturity for the underlying supporting process.
And then the last thing that you want to think about is, are you doing it efficiently? So how you're doing it, and if you're doing it, but you also want to know, does it make sense? Are you spending more money to do less? Are you paying a sort of a reasonable amount for that control, or are you overpaying for the control? There's the classic example of, you don't insure a $300 car that's old and about to die. You don't pay $2,000 a year for insurance for the cost of replacement of that car, because it doesn't make sense, right? You want to get that right measurement, that right balance between the budget and the efficiency. So you want to make sure that what you're paying for, you're getting over and above that, not that you're paying more than what you're getting for. And that's where the economic modeling tools can really come in and help you understand how much you're paying for each control, in addition to how well it's being used and the maturity of that control.
Absolutely true. And all of those things kind of tell you a little bit about your control environment as it exists right now. But there's more that you need to know in order to be able to do a full kind of current state analysis, right? The next step is, you need to understand your own internal threat environment, and who's trying to compromise you. So so one approach to understanding kind of that threat environment is to use a threat modeling kind of approach. There's multiple different ways to do this. There's things like application threat modeling that you may be familiar with. But there's been along the way, threat trees and other strategies for how to evaluate the attacker's eye point of view. But really, all this is saying is that once you understand kind of that initial, baseline environment, you also want to understand kind of the threat model or the threat environment in which you'll need to operate.
Yeah, the misuse cases, how can people abuse it? And back in the day, sometimes we would call, before threat modeling became a common term, we often called threat modeling, what we did was risk assessment work around specific use cases or controls. So it's not unusual that to bring back in risk assessment frameworks in this process as you're doing the analytics. So we talked about some of the maturity frameworks and some of the risk frameworks, but again, ISACA's risk IT framework is one that you can bring in. And for fans of Jack Jones also, or just fans of FAIR, the FAIR analysis of information risk is another risk assessment framework that can be brought in to help you understand how you can connect threats and weaknesses in the current state. So Ed was talking about web apps, for example. So, there's attacker to your web app, you've got vulnerabilities in that app. Say it's, vulnerable to SQL injection, something really simple that everybody knows. What could that do inside of your organization, and what damage could be caused? Could that become a pivot point for someone to get in to, impact the integrity of the data in your database, for example? So you start using these frameworks to help you think in a sort of formalized way around how you bring threats and weaknesses together, and see where you want to go ultimately too, because that's a really critical part. Another framework that some people use is CSF, and the NIST CSF. And that focuses a lot on the targets, because it can be very easy when you're building architectures, again, to sort of get lost in your own work. And companies can kind of get lost in where we are and what's happening, and forget that most importantly is where you want to go. So frameworks can really help you with those target states. They also help, again, with that repeatability, that being able to reproduce what you're doing, so that we get out of this manual loop that many times happens with cybersecurity architecture. Start getting into a repeatable process that you can do over and over. And frameworks really help with the thinking around that. And Ed, I don't know if you want to add anything on frameworks, because I know you've done a lot of work with them too.
Yeah, I was just going to say, the one thing that I think is kind of helpful, at least it's helpful to me, is that when you think about risk, right, it's impact times likelihood. So like when you're kind of looking at your architectural process, like, how do you answer the question about the impact? Well, you need to understand kind of your current environment, right, in order to be able to do that. And then how do you understand the likelihood? Well, you need to understand the threat environment in order to do that. And then you put them both together and you plug it into, whether you use a framework or not, but you kind of plug it into a risk assessment process or risk analysis process. And at the end of that, you have kind of a risk-based view. So these kind of three things that we're talking about are kind of synergistic in the way that they work together.
Absolutely. And so on to our first tool on gap analysis.
Yeah, absolutely. So the first one, so to try to understand the, for doing that kind of gap analysis piece that we were talking about, right? The Aramba tool. So this is advertised as being open source. The only caveat to that is that, so for folks who are, real kind of, fire breathing, like, open source people, I happen to be one. I'm on Linux right now, right? But if you're really into open source, like, the license is not OSI approved, but but it is free, and it does, the license does give, some elements of what folks would consider to be an open license to it. But really, what this is helpful to do is to evaluate, kind of doing that baseline assessment. You can use it from an effectiveness point of view to understand kind of, whether you have a given countermeasure in place. You can use it from a maturity standpoint to evaluate the maturity of the supporting processes. Really what it is kind of a GRC platform.
And one of the things that we talked about was efficiency and whether or not you're spending too much for control versus what that control is giving you. So looking at another gap analysis tool that can help with analytics is actually the TCO tool itself, which is open source, and it helps you model the total cost overall of the ownership of that tool. So that means both what you're paying, right? Because a lot of times it's like, well, the licensing fees are X, but the actual care and feeding of a tool may be extremely, or control can really add up. I remember way back when SIMs were very new, and I worked at a vendor that had a SIM, that the cost of the SIM, the license cost, if that was X, the actual cost of implementation and total cost of owner was 10 to 20x per year, which if the company was getting that kind of value out of the tool, that's fantastic. But it's a really good reminder of how much that the licensing doesn't cover everything. You really also have to think about the soft cost of your resources and your people. And how they're interacting with that control to get a real idea of the total cost of ownership. So a tool like this can really help with that gap analysis on efficiency.
Absolutely.
Here's
so
one
this
of your
is a tool,
favorites.
Yeah, this is a tool I use a lot. So there's a few different tools out there that do threat modeling and do it well. So everybody knows about the Microsoft threat modeling tool. I personally like the OWASP Threat Dragon tool. It's open source. It's the Apache license. It's really good for. It's much simpler. It has a lot less kind of fancy shapes than the Microsoft tool does. Not to ding on the Microsoft tool, but it's kind of less fancy in the shapes that it allows you to use. But the workflow is easy. It's simple to get a model up and start actually interacting with it and assigning, looking at the threats and working through, stride analysis of it. Creating a data flow diagram, if you've ever tried to do this in like PowerPoint. So people always say, why not just use PowerPoint? If you ever try to do this, it's really difficult to do it in PowerPoint, I think, because, to do things like the boundaries and have the curved arrows and all that. I find that to be difficult to do. So this has some helpful automation. It's not super heavyweight. It's free. So I just really like this particular tool.
Another tool for threat modeling is Trake, coming out of MIT. And this one is really nice because it gives you the ability to document who the actors are and the data and how they all interact together. So it's a really nice complement to the kind of to a Dragon type tool.
So it's MIT licensed for sure, but it may not be MIT the school. So just one quick point there. Speaking of FAIR, so the FAIR, so the open group has a FAIR specific tool. So this one, I think this may be the only one that's in this group, but this one is not actually open, like fully open source. So this is a 90-day evaluation license that you can obtain if you want to use it. Basically, it allows you to do probability-based risk assessment, risk analysis, to help you automate kind of the process that you would go through, from a fair, if you're going to go through kind of a fair-based exercise. So there's things like, Monte Carlo simulation and whatnot that's built into this, so that you can kind of, get kind of like that probabilistic view of it.
Yeah, that's one of the things I really like about this, is that you can play around and change numbers so that you can get different views, which is a really nice thing for visualization.
Great.
Okay, so now we're going to move on to the informational tools. And these are the tools that, again, these are the ones that help you to gather and track and analyze the information that's in your environment. So looking at things like what your performance indicators are, what your risk indicators are. And then a big problem that, if you do any security assessments, one of the first questions is, do people have an inventory? So these are the tools that can start helping you get a handle on what's in your organization, where the devices are, who the users are, where the licenses are, and where your data happens to be.
Yeah, absolutely. So you can really use these metrics kind of anywhere along the architecture process, right? You can use it as part of your current state assessment. You can use it as you're planning your future state. You can use it to track the implementation, and obviously to make sure that you're successful at the end. But key performance indicators, key risk indicators, these are the things that you're looking to distill this information down into so that you can track.
And of the tools, there's Grafana, which is its commercial and community version. But what it is, it's a dashboard. So you can start to see graphs you can do a number of different graphs of almost anything. But if you start using this for operational metrics, it can help you report out on where you are.
Yeah, this is really good for, basically tracking anything, and dashboarding anything. I mean, you could dashboard, your
energy use.
Exactly, your energy use or anything like that you can put together. Yeah. So this is not a security specific tool by any means.
But it is great for visualization.
That's true. The next one, this is kind of like this is going old school, right? So this is an open source tool for basically asset management, inventory management. So this allows you to inventory anything. It can be hosts, can be virtual machines, containers, data centers, people. There's, you can really just inventory whatever using this tool.
And again, if you're not doing inventory or organization, somebody needs to be doing the inventory. And this is really a step up from the traditional spreadsheet that a lot of people, no ding on spreadsheets, but they're not the best inventory tool. So if you're ready to graduate from something, but not ready to buy a sort of heavyweight inventory tool, that's a great option. And then,
Diana, I know this one's your bailiwick for sure.
Oh, yeah. So network management and being able to get the view, right? When you're a network admin, you want to know everything that's going on, all of your network, what's not working, what is working. And so if you want to use an open source tool, you don't have the money for a commercial tool, this is a fantastic option, OpenNMS. And it'll help you with looking at the data collection, understanding what devices you have and what they're doing, and then reporting out on how effective they are. If you've got outages, for example, if you've got some really unusual activity in one part of the network, this tool is a really great way to start to hone in on where those problems may be, or to just get reporting and analysis on things are going well.
Absolutely true. All right, and then just from, in terms of reference materials, so one reference material that I've just found handy is the CSF reference tool. So this is just a public domain resource from NIST that allows you to look up, basically what's in the CSF. So this is helpful because keep in mind that the CSF is mapped to a lot of other different things. So it can be kind of a useful crosswalk in that way. And this can help support your gap analysis, particularly when you've got metrics coming in. You want to kind of sort those metrics and understand how they play into a broader picture.
Exactly. All right, so now we are on to the documentation tools. So looking at design and documentation. And you want to start with, you want to have a software architecture description, So the way we like to say, just remember that you'll be sad if you skip this step. I know that there's this real movement towards, oh, it's DevOps and we're super agile, but that doesn't mean not to document. And really, in the long run, as much as it may feel like a bit of an overhead to do documentation, and that's why we're going to give you some tools to maybe help with that. It really, in the long run, is one of the best things that you can do, because you won't get lost inside your own architecture. You won't ask yourself later, why did we not have this control? When an assessor comes in and says, why do you not have this really important control? Well, if you've documented why you decided to have an exception and not include that control, then that's going to really back you up. And you may think, but I won't forget that. But it's really surprising how often that people do forget why decisions are made. It may have been somebody in a business unit that wanted to override a recommendation. So you want to get this you want to get your documentation down. And as you're doing your documentation, some things to capture, and this is summarized from the TOGAF ADM, is you want to understand the scope of what you're doing with your architecture, the goals and the objectives, the principles themselves, and those principles are listed in section 32.2.4 of TOGAF 9.2. And then this is also where you come in with your impacts and your transition phases. So you start to get a handle really around what you're doing overall with the program, and also to remind yourself as decision points are made as you deploy out that architecture.
So just one thing to keep in mind that we want to just hammer on: 32.2.3 is where in TOGAF the architecture description document is, but we really wanted to hammer on the principles piece because a lot of people forget it, and it's really important to. So if you go to that, those two sections are useful if you want to understand kind of the TOGAF process.
Yes, that's true. Yeah, .2 and yeah, and actually all of TOGAF, but yeah.
Yeah, well, there's that too. So great. So from a modeling standpoint, there's a number of great resources. We're just going to run through them. Generally speaking, so I was started off as a developer, right? So I'm kind of a UML guy. I love UML and I use it for all kind of stuff, but it's not by any means your only option. Archimate is kind of the architectural modeling language that that TOGAF has and makes available. So those are really kind of the two that, at least initially, we're going to focus on from a tool standpoint. The first one being the Archie tool. So the Archie tool is specifically created for Archimate diagrams. It's a really good tool, a really powerful tool. The problem is the UI, like the UI though, right? Like what people would say nowadays. So the advice that I would give people, if you're going to use Archie, read the manual. Like seriously, RTFM, because it's really, I personally at least found it very difficult to navigate the UI before reading the manual. So just understand that if you're doing Archimate, the Archie tool is kind of designed to do that diagram and modeling for you. From a UML standpoint, though, the open source tool that I think has advantages is Modelio. So Modelio.org, open source GPL v3, lets you. It lets you do Archimate. It lets you do other types of modeling too. But where, at least in my opinion, where it really excels is with UML. Now this one, much like the Archie tool, is also kind of a little bit of a beast from understanding how to use it and kind of getting familiar and conversant with it. In this case, though, the getting started tutorial, and there's some great written resources and also some video resources that are out there, are really good for kind of just getting up to speed and kind of figuring out where you are in the UI and how to get started.
And this next one is about mind mapping. And I have to say that I sort of went kicking and screaming into doing mind mapping, because at first I was like, is it just some another annoying way for people to think that they're like looking cool or whatever? But mind maps actually are really, really helpful, especially when you're trying to get security requirements from a number of stakeholders across an organization, because you can start just with brainstorming and you start to see patterns and interconnections will begin to appear as you use a mind mapping tool. So if you've been a little bit resistant, like I was, I don't know, Ed, I don't think you were resistant about mind mapping. I do have to say that when you're looking at doing architecture, and especially as you're gathering security requirements, mind maps can actually be very, very helpful. And this one is a nice free tool to be able to do that. I don't know, what's your experience with mind mapping, Ed?
Yeah, I mean, I use it a lot. I use it for, in particular to understand kind of like the scope of stuff. Because, what I like about, so I was a latecomer to mind mapping too, but what I like about it
Okay.
is you can drag, you can put stuff on there and then drag it and reorganize it as you want, right? So you can move a whole tree's worth of drill down in kind of one fell swoop. So it's really helpful when you need to move data around or, move items around quickly.
Yeah, and especially and when there are a lot of you have so many ideas too. Like sometimes until you've started to put them down, you don't start to see the grouping, and people will start throwing. Well, we need this, we need that, and then yeah, a mind map can really help with that grouping, especially as you noted, because you can do that sort of automatic recalcing when you add something to a different group.
Okay, and yeah, absolutely true. And this one's a little bit of a specialized one. So OSATE, or OSATE 2, I guess I should say. So this tool is a great tool for the specific purpose of embedded systems modeling. So this is kind of like a you'll know it. If you need a tool like that, you will know that you need a tool like that. But we wanted to mention it because for the specific purpose of embedded systems modeling, for those folks who have to do that, like if you're working in robotics or with IoT, for example, this can be an excellent tool to help you develop that.
And again, it's a great point about, this is about building your toolbox. We're trying to give you a number of really good tools that we've used that we found helpful, but your toolbox is going to be unique to you because remember, you're the most important tool in your toolbox. You're the tool or the towel. So remember that as you're going through this and thinking about this afterwards about what does your toolbox look like for your security architectures. So bringing this all together, we really would like to underscore that being able to visualize what you're doing and finding tools that can help you collaborate with others will really help to lift out of that very, very manual, very one-off kind of security architecture approach into something that's going to be more repeatable.
Absolutely, and these are the tools that we use, right? I mean, keep in mind that the best tool is the one that fits into your process and knows, like, so for example, right, when I'm doing security architecture work, I use a very heavily modified, most of the time, version of the TOGAF, the TOGAF process, right? But that's not to say that you have to do that, right? If you have a different approach that works for you, like maybe you're more into SABSA, right, than you are TOGAF or what have you. Like basically look for the tools, whether they're these or others, that kind of fold into your process and that best support what it is that you're trying to do.
And don't forget the core principles. Remember to be adaptable and to be a little bit flexible as you go along the process of building out a security architecture, especially when you have a number of stakeholders. There may be compromises. There may be areas where you have to bend or flex a little bit, and that's okay. And some of these modeling tools, again, can be really helpful for you to understand, well, if we make this change, what's the impact over here in another part of the architecture, another part of the organization?
Absolutely true. Absolutely true.
So how can people apply what they learned today?
Yeah, so I think a good way to start, right, would be to look at what you're doing now from a security architecture planning standpoint, find those inefficiencies, just look at it the way that you would any other kind of process, and then, think through, how can you improve that process both procedurally, but then also how can you help to automate it using these types of tools. And then as you start to figure out where you can grow and how you can improve, then kind of build on that baseline and look for additional free tools out there or commercial tools or what have you. And then really most importantly, like kind of over time, collect out the metrics that you need to be able to measure not only how your designs fare once you push them into production, but also how your architecture process itself performs, right? How can you improve the way that the reliability, the maturity, the resiliency of the architecture process itself? And keeping these meta metrics, that's really important too, right? Understanding how long it takes you to put together your documentation, for example. How can it be streamlined? So these are things that not everybody always looks at, but it can behoove you to.
Yeah, and architecture is not a point in time activity. It's an ongoing journey of optimization. And that's, again, as Ed was pointing out, once you start building more automation in, you can find that that optimization gets easier and easier, and you can bring the lessons of the past. Looking at a lot of companies who got caught out, for example, because they had these sort of older, brittle architectures from a decade ago, when suddenly, especially for VPN deployments, when they had to start working remotely entirely after COVID, they had to just completely rethink. Whereas when you're in this ongoing optimization approach to your architecture, you're not only able to stay ahead of some of these trends before they catch you out, but you also can learn from the past. So with that, we want to thank you so much for listening to this talk. As promised, here are the references. All of the tools that we talked about and all of the links to get to the tools are here on this slide. So
Yeah, thank
you so much for listening to us. Thank you, Ed, for presenting with me. And we'll see you next time.